reason I'm creating this video for you is because I've actually run out of CO2 on my Aquascape 600, and I thought rather than just fitting the new bottle and going through the whole process myself, why not share it with you guys, and then why not make an educational video for hopefully you to enjoy. Hi everyone, George here and welcome to another video from the GFS gallery. It's been a little while since I sat on this sofa, hasn't it? Today we're going to talk about pressurised CO2 kits, and Tommy's come into the picture. Tommy's 1 year old exactly today, and it's my birthday tomorrow, and yesterday we reached 100,000 subscribers, so it's been a very exciting time for everyone, isn't it? Let's talk about CO2, let's talk about why we want to use it in a planted aquarium or might want to use it, and let's talk about pressurised CO2 in particular. Why would we want to add CO2 into an aquarium? CO2 is the best source of carbon for plants to use. A plant is almost half made from carbon. It's a carbon-based life form, just like we are. Plants photosynthesize. They use light and CO2 to grow. It's called photosynthesis. So the more CO2 we add, potentially, the bigger and quicker the plant can grow. Now, in an aquarium without any CO2 injection, so we're not actually deliberately adding more CO2, there's a background level of CO2, which depends on the system, but it's around about 4 parts per million. If we want to get faster plant growth, better plant growth, we can increase that CO2 level. Usually the maximum recommended is about 30 parts per million, and we need to artificially introduce extra CO2 into the aquarium water using a CO2 system. There's many CO2 systems available on the market, there's probably hundreds. There's aerosol systems, there's electrolysis systems, but by far the most popular and arguably reliable and controllable method is via a pressurised CO2 system. Now there are you can split the pressurised system into 2 categories. So the cheapest and probably most accessible pressurised CO2 system is the disposable system. This is specifically designed for nano aquariums. It's only a 95 gram cylinder. It's a one-shot use only. So once it's run out, we throw it away or recycle it ideally. It's very, very simple. It comes in 2 main parts. Here we have the bottle. This has been used up, it's empty right now. If I took that off and it wasn't empty, we would have high pressure gas coming out of there, very, very dangerous. So before we start, in fact, full safety disclaimer, treat pressurised CO2 with absolute respect. 1, the very high pressures involved can be fatal. 2, CO2 is actually toxic. So if you're in a confined space and you have a big CO2 leak and the atmosphere has too much CO2 in it, it can actually cause unconsciousness and actually death. Too much CO2 in the aquarium will also kill the livestock quite easily. In fact, in high-tech planted tanks, guys that are using pressurised CO2, probably the #1 cause of fish fatalities is adding too much CO2, or there's been a problem with the CO2 system. We'll talk about that later on. So, disposable cylinder, the regulator. This is super high pressure and it needs to be brought down to a safe pressure, which is what the regulator's for. So that screws on there. This has a little cap which pierces and self-seals once that's screwed on, so you won't get leaking gas everywhere. Let's pretend this is full. And then you've got a pressure contents gauge here, and that gives you an idea, how much CO2 is in there. So when it's full, it'll read about 1000 psi at room temperature. The warmer the ambient temperature, the more pressure you get, just because of the laws of gases. And then we simply have a needle valve here, and this controls the amount of CO2 that's coming out of here. We attach a CO2 proof hose to here, and at the end of the hose we add a diffuser. That diffuser then goes into the aquarium, and that CO2 gas dissolves in the aquarium water and feeds the plants. Relatively simple, relatively straightforward. Now moving on to our higher end, much higher end regulator. It's a very similar process in terms of we're using high pressure cylinder here. This is actually a fire extinguisher, CO2 fire extinguisher. This is a very popular method of adding CO2 cylinders in the UK. So let's talk about this regulator in more detail, and I'll go into close-ups on this because there's some important components to tell you about in more detail. So we'll move over to the table and then let's take a closer look. Here we have a close-up of the regulator. As you can see, this is from CO2 Art. This is what we call a dual stage regulator. So I'll go through each component part to the regulator and hopefully be able to explain it in more detail for you. We'll start off with where the gas comes in. So this piece here, this attaches to our pressurised cylinder. In this case, we're using a 2 kilogram fire extinguisher with pressurised CO2. So we attach this using a wrench or an adjustable spanner. This brings the high pressure from the fire extinguisher down to a much safer pressure. When we eventually add this to the fire extinguisher, which is what we'll do later, you'll see this contents gauge here. This will shoot up to around about 1000 psi, which is about 60 bar. It's 14 psi in 1 bar. So depending on what type of regulator you have, you may see a different unit of measure. The interesting thing about this regulator is dual stage, which means we have an adjustable working pressure, this dial here. So the working pressure is indicated on this dial here, and we can increase that or decrease the working pressure by turning this. Let's assume that we've attached it to our cylinder. This fires up to around about 1000, and then this will be set according to what we've set on here. Now normally for most situations 30 psi will be plenty, maybe a little bit more depending on the type of diffuser you're using. So this is the actual pressure that's now available to our diffuser. In a single stage regulator like we had with the disposable system, I'll go and get that now. In our disposable system we only have a single stage, so there's no working pressure adjustment, it's just contents, and then we adjust the output with this dial here. And what this means is you can get what we call an end of tank dump. This means that once the CO2 starts to run out, in some situations it can get rid of all of that last bit of CO2 in one go, which can be potentially very dangerous for the livestock in the aquarium. So this is something to bear in mind, and this is why I would tend to recommend a dual stage regulator if you can, because you have control over the working pressure here, and if and when the tank does begin to empty, it's not going to dump all of that CO2 in one go at the end. So end of tank dump is a potential problem that you can experience with single stage regulators, so do bear this in mind. I've never actually experienced end of tank dump myself. Let me know in the comments if you have, but it is a situation that I know has occurred with some friends and colleagues, so always worth investing in the more expensive dual stage regulator if you can afford it. CO2 in here with our pressurised cylinder, we'll attach that later to the fire extinguisher. Working pressure adjustment here, contents pressure here, how full the bottle is, working pressure gauge here, how much CO2 pressure we've got to use actually in the aquarium. Now moving on down here we have our manifold, so the CO2 comes down here. This is our solenoid here, so this is actually an electromagnetic device which is powered by electricity. We plug it in, normally into a plug-in timer, which I have here, and this opens the valve when there's power applied. So if we want CO2 coming into the tank, we make sure this is turned on. If we don't want CO2 in the tank, i.e. at night when there's no light to use the CO2, we can have it turned off, and that's why a timer is a good idea, so we can automate that process. Let's say the CO2 is on, the solenoid is working, there's normally an LED lamp there. I'll show you later it working, and you can hear a clicking noise as the electromagnet fires up. Then we have our needle valve, that's this piece here, and this is for fine adjustment of the CO2 gas. We have a bubble counter here, so this is filled with water or another safe liquid, and we physically count how many bubbles are coming out of there in a certain time frame, normally per second, and we can adjust this to achieve our required bubble rate, the amount of CO2 that's being added. As a very rough rule of thumb, I go for 1 bubble per second per 50 litres of water. which is about 12 US gallons. So 1 bubble per second per 12 gallons of water. This is a very rough estimate. In fact, I do have a comprehensive video on how we test for CO2, and I'll link that at the top of the screen now and also in the description. Very brief overview of the CO2 regulator. Might sound quite complex, but it's worth going into some detail on this, and it's worth investing in a good quality piece of kit if you can. Just one last thing here. This is a pressure relief valve, so if and when you needed to disconnect the regulator and there's still gas built up in the regulator, you can pull this and that excess gas will just release out of here. Now I'm going to fit the regulator to the cylinder. So first thing I'm going to do is take off the fire extinguisher horn. Now, like I said, many of you may not be using fire extinguishers. I would encourage you to buy a regular aquarium cylinder. Support your local aquarium retailer if you can, but if you can't and you don't have the budget, especially if you're in the UK, it seems fire extinguishers are a lot more popular. Okay, so I've taken off the horn. Now we can actually attach the regulator to the cylinder. So it's important that we have our seal there. That's to prevent any leaking. Tommy's there. Hello, Tommy. Do you like the regulator? And then we just simply screw this on with our fingers to start with. And then using our wrench or spanner, not super tight, but fairly tight. Obviously we don't want any leaking. Okay, now it's the most dangerous time, so we're actually going to activate the cylinder or turn the cylinder on. If you had a regular kind of aquarium cylinder, it would probably have a rotating valve. This is just a press valve. So the next step is to open our cylinder valve here, which we press, and then I have a cable tie which we can wrap around to make sure that stays shut, and then we'll see what the contents pressure goes up to. You can hear that, that's leaking. So let's try tightening it up a bit more. There we go. Not sure if you heard that hissing, it's now stopped. So now we have our contents pressure there, just between 500 and 1000, so about 800 psi. Our working pressure, so contents pressure, the contents of the cylinder. Now our working pressure, as you can see, is around 30 psi, so that's ideal. And we can adjust that with this here. So now just attaching my cable tie here. So keep an eye on the solenoid, its red light should light up hopefully, and you should hear a click. I'll give you a demonstration of the working pressure now. So we're on about 30 psi. If we want to increase it, we rotate the working pressure dial clockwise. And if we want to decrease it, we rotate it anti-clockwise. But for it to actually reduce, we need to let the gas out. The gas is now built up in the regulator. So to let it out, so let's turn it all the way off. There we go. Now let's say we want to set it to 60, which is a bit too much really, but there's no harm in doing it at 60. Let's set it to 60. And now we can set our bubble rate. So here's our needle valve. Rotate that very slowly anti-clockwise. Open the valve and you should see the bubbles coming out. So now we can just, you only need tiny movements and you can go as high as you want. So in a very large aquarium, you know, you can go up to 5-10 bubbles a second. For a smaller aquarium, say 10-15 gallons, one bubble a second or so, or even less for a nano tank. And that is it. Now we connect our CO2 hose and diffuser to here, that goes in the aquarium, and then we have our CO2 delivery system all set up. Now we have our CO2 kit inside the Aquascape 600 cabinet. Now it's simply a case of attaching our CO2 diffuser to the regulator. So we come through the side hole here, and then we have our attachment nut here. This just slides on to this nipple here, and then we can secure that with the attachment nut. Now I want to run quite high CO2 in this tank. Plug the solenoid, you can see that's on. Now let's adjust our needle valve to about 3 or 4 bubbles per second, and then you'll see the CO2 bubbles coming out of the diffuser in a moment. Let's go show you that right now. So now you can see the CO2 diffuser in action. This is an in-tank diffuser. You can get inline diffusers. CO2 diffusion is a subject for another video. So I usually have the CO2 come on about 2 or 3 hours before the lights come on. This gives the plants opportunity to use that CO2 as soon as the lights come on. You could have the CO2 come on at the same time as the lights, but the CO2 won't be dissolved so much in the water. So we often have the CO2 come on before the lights go on, and the CO2 normally goes off just before the lights go off, so the plants can use that residual CO2 that's in the tank. Okay guys, I hope you enjoyed that guide on how we can use pressurised CO2 systems. Thanks so much to CO2 Art for supplying that regulator. CO2 is a relatively complex topic. We could talk about CO2 testing, the dangers of CO2, circulation of CO2, nutrients and CO2. It is a very kind of big topic to cover in planted aquariums and aquascaping, so maybe I'll do some more CO2 videos further down the line. Let me know in the comments what you'd like me to talk about next, maybe in the CO2 world, or do you want me to cover something else, substrates, fertiliser. I do tend to focus more on aquascaping, but I think it's nice to delve into some sort of technical matters now and again. So let me know what you think about this style of video in the comments. Before I go, I have got a confession to make on the Aquascape 600. The lights have been off for 3 weeks. I ran out of CO2 before I went away on holiday. I didn't get a chance to replace it. I turned the CO2 off whilst I was away on vacation, and I've just been so busy doing other things, I haven't got around to fitting CO2. So I've had the lights off for, like I say, 3 weeks. A lot of the plants are really struggling. I might plant some new plants, let the kind of die-off occur, and then replace those with some brand new plants. We'll see how we go. I'll give it a week or so, see how much kind of regrowth I get. But just to let you know, it's not looking great right now. This is the first time the lights have been on this aquarium for 3 weeks, so not a great start to this aquascape's life. You can watch the full build of this scape. There's like a bit of a tutorial video on Iwagumi, and I did an update video on it as well. So do check those out. I'll leave links to those in the description. Should we say bye-bye to everyone, Tommy? Can you come up and say bye-bye? So I'll say cheerio. Thanks so much for watching. Really appreciate you, especially as I've just reached 100k subscribers. It really kind of brings things into focus about what my channel's about and where it's going to go in the future. Just really grateful for all of you. You take care. Keep on scaping. Cheerio.